Hello, I'm Bhaskar from 4GMAT. This is a solution to the diagnostic test that you have taken. In case you guys have reached the solution through a link without taking the diagnostic test, I'll strongly recommend that you take the diagnostic test before looking at the solution. Right? You can access the diagnostic test by visiting our website www.4gmat.com. Right? I'm assuming you guys have taken the diagnostic test. Here's the solution. Right? This is the first question. We'll have a look at the question. It's an interesting number property question which helps us understand a lot of core number property ideas, right? One key area, let me put it that way. I'll read the question quickly. A bag contains 72 red marbles, 45 green marbles and 108 blue marbles, right? It's got three colored marbles of different numbers. These are packed into packets. These are packed into packets containing equal number of marbles of the same color. What we need to find out is what is the minimum number of packets required to achieve this, right? So our final answer is going to be a number which is going to tell what is the least number of packets required to achieve the condition stated there, right? We'll start decoding things what are given in the question. First, the number of marbles, 72 red, 45 green and 108 blue marbles, right? Let's keep that aside. The two things to be decoded. The first one is basically this: packed into packets containing equal number of marbles of the same color. There are two keywords to keep in mind, right? Equal number of marbles in each packet, and any packet that you pack will have marbles of the same color. So you cannot mix red and blue. And similarly, whether I pick a packet comprising red marbles or the one comprising green marbles, I'll find the same number of marbles in it finally. So this is the objective to be achieved, right? Let's get started. Let's try and phrase it in the form of some pseudo equations to help us understand how it works. Right. The number of marbles in each of these packets is going to be the same. So that's what the question says. Number of marbles is the same. I'm going to pick something like each packet contains n marbles. Right? There are n marbles in each packet. So let's look at it this way. We have 72 red marbles. Right? We are going to pack it into packets containing n marbles. Let's say if we make it that way, we'll get a number of packets. So the 72 is going to be equal to a into n. A being the number of packets and n being the number of marbles in each packet. Similarly, if I try to do the same thing with the green marbles, I have 45 green marbles. These 45 green marbles are going to be packed into packets containing n marbles. But the number of packets will be different because we have lesser number of green marbles. So let's say there are b number of packets that we're going to have. So 45 is going to be equal to b number of packets into n marbles per packet. Repeating the same thing for the blue marbles, 108 is going to be equal to c into n, where c will be the number of packets, number of blue marble packets that we'll have. Let's quickly look at these three equations. We realize that n is a number that's going to divide 72, n is a number that's going to divide 45, and n is a number that's going to divide 108. So n is a number which is basically a divisor of 45, 108 and 72, which means n is a factor of 72, is a factor of 45 and is a factor of 108. So n, the number of marbles in each of these packets, is a factor common to these three numbers, right? So that's the first learning from this. We decoded part 1, and what we have got, number of marbles, this number is going to be a common factor, is a factor common to all these three numbers, 72, 45 and 108. So this is part 1 of what we have done. There's one more level to be decoded. We'll just move on to the next slide to look at that. Right. The second thing is, what we are trying to find out is not some number of packets into which it can be packed. We're trying to find out what is the minimum number of packets into which we can pack it. Right. That's the second most important thing that's needed to finally crack this question. Right. Let's say I put one marble into each packet. There are 72 red marbles, so I'll essentially get 72 packets out of it. But conversely, if I put 72 marbles into one packet, I'll get one pack of it. So higher the number of marbles in each packet, lesser the number of packets that we'll get. So that idea is captured. So what we have is more marbles in each packet, more marbles, less packets, right? Is this something that we can take it as inference, right? Higher the number of marbles in each packet, lesser the number of packets that are there. So we decoded in the first slide that n is a factor common to these three numbers. N is a common factor. And we have now come with this second inference that this n should be as high a number as possible. So mathematically what we are trying to find out is, we are trying to find out a common factor, and that factor should be the highest common factor. So net what we are trying to have is the number of marbles in each packet, this n, is going to be equal to the HCF of these three numbers, 72, 45 and 108. Right. So now we have understood what we are going to do. The next step is the mechanics of actually finding out the HCF. Right. We'll just go about it. There are two ways to finding out the HCF. The first one is what in my school days they used to call it as the L division method. So this basically starts this way. Take 72, take 45 and take 108. Pick a factor or a number that you think that can divide all of these things. See, ideally, the larger the number you take, the lesser the number of steps that you can go. I'll decode it and we'll do it in a couple of steps in this particular iteration. Right? I know for a fact that 3 will divide all these numbers. So I'm going to divide all these numbers by 3. 72 by 3 is equal to 24. 45 by 3 is a 15. 108 by 3 is a 36. Right? 24 is also a multiple of 3. 15 is also a multiple of 3. And 36 is also a multiple of 3. So the result of this division is further divisible by 3. So I'll divide it again by 3. 24 by 3 is an 8. 15 by 3 is a 5. And 36 by 3 is a 12. Right? So quickly if I look at it, 8 and 5 do not have any factor in common. 5 and 12 do not have any factor in common. These three numbers, 8, 5 and 12, together if I look at it, they don't have any more factor in common. So I cannot pick any factor common outside. So what is the HCF? HCF is basically the product of all these factors that were taken as common one. In this case, you have taken a 3 and a 3. The HCF is going to be equal to 3 into 3, which is equal to 9. So the HCF of these three numbers is equal to 9. Right. This is method number 1. We'll hold this thought here and then we'll move and find out a second method of finding out the HCF and then come to the final answer. Because is this the final answer? This HCF actually gives us the number of marbles in each packet, while what we need to find out is something very different. Right? We'll come to the second method and then go on to that step. The second method is what is known as the prime factorization method. The prime factorization method, what we are going to do is we are going to prime factorize each of these three numbers. Let's start by prime factorizing 72. Right? There are two ways of going about it. I'll just walk you through this one method which I think will be faster. The other one will deal it in a separate video later on. Right? 72, as I look at it, I can write it as an 8 into 9. Quickly I realize that 8 is not a prime number. So I'll try and prime factorize 8. 8 is actually 2 raised to a power of 3, 2 cube. And similarly, 9 is also not a prime number. I can prime factorize 9 as 3 into 3, which is therefore equal to 3 square. So I basically written the 72 into some two parts that I know, which struck me first. And then I quickly realized to see that some of those parts, in this case, neither of those parts is basically a prime number. I prime factorized those and got the answer. We'll quickly run through the same process for 45. 45, if you look at it, it's basically 5 into 9. 5 is prime, but 9 is not prime. So we'll basically prime factorize 9 and write it as 3 square. The last number, 108, I'm going to prime factorize it. When I look at 108, immediately strikes me as a 9 into 12. So 12 into 9. 12 is not prime. I'll quickly write this 12 as a 4 into 3. 9 is neither is 9 prime. So I'll write it as 3 square. The next step, 4 is also not prime. We can write 4 as a 2 square. We'll write it as a 2 square and combine this 3 and 3 square and write it as a 3 cube. So prime factorize these three numbers, 72, 45 and 108. To find the HCF, what we are going to do is we're going to pick out all prime factors that are common to all these three numbers. 2 is a prime factor of only 72 and 108. So we are not going to take 2. 2 will not figure in our list. So 2 is not going to be there. Right? 3 is a prime factor of 72. 3 is a prime factor of 45. 3 is a prime factor of 108. So 3 will feature in our HCF. 5 is a prime factor of only one of these numbers. So 5 is not going to be a part of our HCF. Similarly, these are the only prime factors. The prime factors we have are 2, 3 and 5. 2 and 5 are not prime factors of all three numbers. So we are not going to take them. 3 is the only prime factor common to all the three numbers. So you need to pick that prime factor which is present in all the numbers. One more step to arrive at the HCF. Pick that 3 in its lowest power in all these numbers. In this, the power of 3 is equal to 2. In the second number also, power of 3 is equal to 2. In the last number, the power of 3 is a 3. So we're going to pick the power of 3 as 2, the lowest power. So the HCF is essentially 3 square. Right. So if I can summarize how to find out the HCF in a single sentence using the prime factorization method, basically is this: prime factor is the 3 numbers. HCF is the product of the common prime factors in its lowest power. You'll have to pick that prime factor which is common in all the numbers in its lowest power. So whether we went about this first method or the second method, the HCF is equal to 9. And what does the HCF stand for in our question? HCF stands for the number of marbles in each packet. Right? What we actually need to find out is not the number of marbles in each packet. We need to find out the number of packets made. So 72 red marbles which are being packed into 8 packets, each containing 9 marbles. So obviously number of packets A is going to be equal to 72 divided by 9, which is equal to 8. Similarly, the 45 green marbles have been packed into B packets containing 9 marbles each. So B is equal to 45 divided by 9, which is equal to 5. The last one, 108 blue marbles have been packed into C packets containing 9 marbles each. So C is equal to 108 divided by 9, which is equal to 12. So I've got 8 packets containing red marbles. I've got 5 packets containing green marbles, and I've got 12 packets containing blue marbles. So how many packets do I have? 7. 8 of red plus 5 of green plus 12 of blue, which adds up to a total of 25 packets. Right. So our answer to this question, basically, you have 25 packets. It's the least number of packets that you need if you have to achieve both these conditions. Answer choice C is the correct answer. So looking for additional questions, test preparation help for the GMAT, visit our website www.4gmat.com. We have a classroom preparatory program in both Chennai and Bangalore in India. We have loads of questions available on our website. We'll soon be starting an online program too. If you have any queries or any doubts, send your comments and feedback to us at info@4gmat.com. If you like this video, share it with your friends. Best wishes for your GMAT preparation.